sieci i zdolność transmisji danych jest nawet kilkaset razy wyższa. Jakie są główne korzyści sieci LTE-450? To podniesienie bezpieczeństwa poprzez efektywne wsparcie służb dystrybucyjnych w przypadku awarii, tak aby szybciej reagować i usuwać ich skutki. To zdalne zarządzanie infrastrukturą energetyczną w celu poprawy ciągłości dostaw energii, czy też zdalny odczyt liczników energii umożliwiający tworzenie lepszych taryf dla odbiorców. To wsparcie rozwoju odnawialnych źródeł energii OZE. LTE 450. Nowoczesna technologia, bezpieczeństwo, niezawodność, przyszłość.
Od tysiącleci człowiek odkrywa świat oraz mechanizmy nieżycia. Napędza nas
Raz, 2, 3.
lepszego zrozumienia świata. Potrzebna jest do tego
Raz.
i odpowiedzialność, która sprawia, że naszą wiedzę wykorzystujemy.
Nie, tutaj.
Podstawowym obszarem naszej działalności jest wydobycie gazu ziemnego, ropy naftowej oraz sprzedaż tych surowców. Jesteśmy liderem rynku gazu w Polsce, notowanym na GPW. Działamy globalnie.
Raz.
Prowadzimy badania.
Raz.
Ma to kluczowe znaczenie dla ekspansji i przyszłości naszego przedsiębiorstwa. Jesteśmy wiarygodnym i pewnym dostawcą do naszych partnerów biznesowych i klientów. Gwarantujemy stałość dostaw i najwyższą jakość produktów. Zapewnia to naszym kontrahentom poczucie bezpieczeństwa i warunki stabilnego rozwoju. Strategia działania PGNiG opiera się przede wszystkim na poszukiwaniu i eksploatacji złóż znajdujących się na terenie kraju i za granicą. Dzięki temu Polska wzmacnia swoją niezależność energetyczną. Chcąc dywersyfikować źródła pozyskiwania surowców, importujemy gaz z rynków zagranicznych. Istotna część przyszłych dostaw będzie pochodzić z Ameryki Północnej. Poszukujemy i eksploatujemy złoża ropy naftowej i gazu ziemnego na norweskim szelfie kontynentalnym, a także w Pakistanie i innych częściach świata. Całość tych działań sprawia, że jesteśmy kluczowym gwarantem bezpieczeństwa energetycznego Polski. Gaz ziemny jest najlepszym rozwiązaniem dla każdego przedsiębiorstwa.
Można ściągnąć? Tak.
Korzystując z zasobów tych naszej ziemi, troszczymy się jednocześnie o przyszłe pokolenia. Naszym celem jest ciągły rozwój i dostarczanie
takie
rozwiązań energetycznych.
To masza
Dzięki
też.
temu jesteśmy dzisiaj obecni w każdym polskim domu. PGNiG. Odkrywamy przyjazne energię.
Elektryczna towarzyszy nam w każdej chwili życia. Za stały i bezpieczny przesył energii elektrycznej w całej Polsce oraz bilansowanie krajowego systemu elektroenergetycznego odpowiadają pracownicy polskich sieci elektroenergetycznych. Energii elektrycznej nie da się przechowywać, dlatego w każdej chwili należy produkować jej dokładnie tyle, ile zostanie zużyte. Oszacowanie zapotrzebowania na energię elektryczną i jej bilansowanie to jedno z najtrudniejszych i najważniejszych wyzwań, z którymi polskie sieci elektroenergetyczne mierzą się każdego dnia. Nasza sieć to ponad 14 600 km linii 220 i 400 kV. Wraz z dynamicznym wzrostem zapotrzebowania na energię elektryczną sprostać wyzwaniom nadchodzącym w kolejnych dziesięcioleciach. Przy wszystkich naszych inwestycjach minimalizujemy wpływ na środowisko naturalne i otoczenie. Wspieramy społeczności lokalne i naszych sąsiadów.
Jasne, dziękuję. Bardzo mi to pomoże.
W naszych prognozach dotyczących zapotrzebowania
To jest pan Greiner, rozumiem?
uwzględniamy zmiany zachodzące na rynku energii. Wyprzedzamy je, aby zapewnić bezpieczeństwo energetyczne naszego kraju.
Jakkolwiek państwo chcą. A kto jest moderatorem?
Bierzemy
Pan
aktywny
Strzałkowski?
udział w transformacji energetycznej Europy.
To tak trochę bliżej.
Jesteśmy częścią jednolitego, zintegrowanego europejskiego
Jeszcze jest
rynku
pan
energii
Stany.
elektrycznej.
Nie ma.
Nie ma jest?
Nie ma.
Krajowy
Okej,
system
dobra, to zabieram
elektroenergetyczny jest szczególnie ważny dla bezpieczeństwa państwa.
Pan, można zostawić pana tego, on będzie wirtualnie ten pan Oskar. Ten pan się ma się włączyć.
Sieci elektroenergetyczne
A nie, czy się
wpływają na polską gospodarkę.
Ale było zgłoszone naprawdę.
To use that microphones, most probably.
Sprawdzić mikrofony, czy działają? Działają.
Polskie sieci elektroenergetyczne. Energia w dobrych rękach.
loud and clear, then we don't need it.
Switch on? Włączać jakoś?
Jest włączony, włączony.
Włączony, tak?
Włączony. Ja tam go zaraz odmontuję.
No okej, dzięki, no spoko, jak się nie da, przeżyjemy godzinę. Okay. Good luck.
Thank you. Same to you. It's very nice. It's very good. Hello.
We'll need literally a moment, okay? Because we've got some problem with some monsters.
We're in the court. I'm in the court next Tuesday. I want you to punch me when I leave the first, especially attack me in the corridor.
Only en sån från vår system. Thanks, bro. It came specially for us. Yeah.
So it's impossible not to forget to use this one. Switch.
Yeah.
This demo. Twice on Friday. Just in the 2 weeks ago. It's 18 pieces of coffin, okay? This is like a handstand contest.
Minuta i startujemy. We ready?
Będziemy mieli jednego prelegenta online. On się dołączy mniej więcej w pół do. Informacje od Simona.
Hello, my name is Jan Strzałkowski.
Dzień dobry, nazywam się.
Welcome everyone to our MO Systems panel on BIPV. We have invited our honorable guest.
Na temat zintegrowane z budynkami paneli fotowoltaicznych i zaprosiliśmy osoby z przemysłu szkła, czyli Guardian Glass, Pinkerton Glass i Saint-Gobain, którzy to przedstawiciele tego przemysłu dołączą do nas. Ich mówcy będą mówili o zintegrowanych z budynkami panelach fotowoltaicznych i o wpływie przemysłu szkła i rynku szkła na rozwój rynku paneli fotowoltaicznych zintegrowanych z budynkami. Zaczniemy od Ralpha Greiniera, który przedstawi nam wykład.
Guardian represents Guardian Glass,
Jako reprezentant Guardian Glass, jednego ze strategicznych partnerów ML Systems, i wykład pana Ralfa będzie dotyczył tego, jaka jest rola producentów szkła w Europie, w Europejskim Zielonym Ładzie i
Thank you very much, Jan, for the introduction. So my name is Ralf Greiner. I'm working for Guardian Glass, and I'm in charge of product update. The glass products. So these are the products in the focus. So what is coming in the regulations, and this is really exciting because that's a short excursus also into the history. You might remember in 1992 there was the Rio conference, and that was the first one really having a global approach related to sustainability and also climate in the focus. In 97, there was the Kyoto conference. Maybe you remember the Kyoto Protocol, and that was the conference actually where first time the CO2 certificate or the emission trade was introduced. So and now we have more than 20 years later, we have the so-called European Green Deal. So that was introduced by the European Commission, and with the goal to become climate neutral by 2050. So, and even earlier, there are really particular steps in front of us, if we look to the key targets by 2030, 32% share of renewable energy, reduction of emissions of at least 55% compared to the 1990 levels, and at least 32.5% improvement in energy efficiency. So, and this is not just a goal, I mean, this is legally binding actually, because there is a regulation behind that. So that means the situation in the European Union that will change dramatically within the next years, and not only in the EU, especially also in the building sector. And the building sector is especially concerned. So, but how can glass contribute to sustainability? So let's have a look into the building sector. So if we talk about glass, so we can say no other material actually provides such transparency, energy efficiency, safety, and durability at reasonable prices. So, and if you look to annual float glass installations in Europe, then we have 675 square kilometers of enclosed area in new, but also renovation buildings. So, and on average, almost 50% of the building facade is glass, but that can be even close to 100% if we talk about high-rise buildings with fully glazed facades. So, and in the last decades, continuous improvements took place in thermal insulation performance, combined with new methods for modulating solar heat and light transmission. I will not go too deep into that. I mean, these are the standard high performance glass products you all know, related to solar control mainly and thermal insulation. And you see that the flat glass products are indispensable to key sectors of the economy. So in the building, automotive, and energy sector. So in the climate neutral EU, and this is also an important message, by 2050 will demand more glass for highly energy efficient windows. And not only windows, actually also glazing and other cladding systems. But still, the building sector is the most CO2 emitting sector in the EU, with 36% of total emissions. So this is a huge number, but the same sector has also a huge potential for energy savings. So, for example, by energy efficient building products. So, ideally with a positive energy balance during lifetime. So, if we talk about passive solar energy gain with a passive house or net zero energy standards, but also renewable energy generation. So, and here we need to talk about heating systems. Of course, this needs to be changed from fossil fuels to electricity, heating pumps, but, and this is our topic today, our main topic, building integrated photovoltaic, because we need to use the surface we have available, or we still create to generate renewable energy in short and midterm, not in long term. This is really a short and midterm issue. So, but it's not only the products itself and the performance. It's also, the approach to stewardship of the glass industry. So, what does it mean? I mean, that's how do we produce products? For example, in terms of material health, material reutilization, renewable energy and carbon management, water stewardship, even social fairness. So, and in order to bring that all together, products are get certified according to certain standards like cradle to cradle. This is a standard also used by architects and consultants and planners if they are looking for sustainable products. And these certificates, on the other hand, they help fulfilling other standards and requirements for green building, like LEED, PREEM, WELL, or DGNB in Germany. So, and this is what the glass industry provides today already. So, with the certifications and also the right approach in terms of product application, but also product development and production. So this is just some examples of certified buildings. So, but let's come to the topic, actually building integrated photovoltaic. So what does it mean? It's the integration of PV, photovoltaic, into building envelopes. And with BIPV, we can provide certain savings. So savings on building materials, but energy cost. So, and what is Guardian doing if in terms of BIPV? We have a cooperation with ML System to offer a complete range because we have recognized that these products providing a sustainable way, producing renewable energy with glass in buildings, that's a key factor in the future. And that's really a big driver also for the European and finally also the global glass industry. So, and what means BIPV? So actually with BIPV we can cover all opaque parts of buildings. So that can be just safety glass, printed glass, all possible shapes, finishes, for all kinds of design, but also transparent in double and triple glazing units. So providing unaltered transparency and renewable energy at the same time. So, and what is the concept behind BIPV? Adapting PV modules to various building applications and to replace other building materials, either glazing or other cladding materials like aluminium. In roofs or in facades, fronts, curtain wall louvres, skylights, balustrades. Wherever you install a piece of glass, theoretically you can install a piece of BIPV. So, and if you look to a typical build-up of a PV module, you see we are very flexible. We can provide a lot of additional performances and attributes. We can use annealed float glass, tempered, patterned glass, etched glass to provide any possible design, and even safety features. So wherever a laminated glass is installed, we can think about installing building integrated photovoltaic. So just a few examples. Here in opaque applications, this is typically combined with printed glass to even hide the silicon cells and to provide any possible look to match also to the vision, to the windows. So, and here you see the possible configurations. So the messages is really flexible and we can really use it like a normal spandrel glass with all the design options we know for spandrels. Here even white look or bluish matching to the windows, to the solar control glass. So, but not only in spandrels, also in transparent applications. That's a simple IG unit. So with solar cells, and you can still look through So the left you can even imagine can be a normal window. The right can be, for example, can be in a roof glazing. So and even here, so many considerations are many configurations are possible and even can be combined with functional coatings. Like here. And last but not least, but I'm sure that you heard a lot already about this new technology. And if we talk about transparent applications, we need to talk about this very exciting step, quantum dot. So generating electricity really on fully transparent glass. So that's also kind of laminated glass. And the good or the very interesting thing is that with the quantum dot technology, I mean, we absorb parts of the solar energy, of the solar radiation, but we can adjust which part we absorb. And this is a little bit, maybe the performance you see on the screen, that's a little bit future music, but this is where we would like to be in a few years, very few years, to provide tailor-made performance with glass which can provide or generate electricity at the same time. So, and this is a little bit the future, but it's not only the future, I mean, it's a very near future, exactly. So, and this is how it will look actually. And for us, this is also the future of building integrated photovoltaic. So, let me conclude. So, the requirements of sustainable construction in the building sector are really strongly increasing, and political decisions are challenging the building sector, but these decisions also offer great opportunities for the entire glass industry and also glass processor to the entire chain in the building sector. Glass can contribute in many applications to sustainable building, as I said, efficiency, but also generating energy. And building integrated PV is really a promising technology for generating renewable energy and reaching challenging targets in reducing greenhouse gas emissions. So, and last but not least, there is also one important fact that we need to take into consideration, not only today, actually always, considering the fact that 97% of today's buildings will still exist in 2050. So the careful selection of energy efficient and sustainable building materials today is critical. Actually not today, it was yesterday already, but today we always need to think about using the state-of-the-art technology and the most efficient products. So, but the good news is the necessary components for a sustainable architecture of tomorrow are available today. So, and this is also the message to all architects, investors, planners, consultants. Everybody in the chain should be aware of the existing products and should consider using the latest technology for the buildings. So, many thanks.
Thank you very much, Ralph, and thank you very much, Guardian Glass, for this insightful lecture. We would like to also stress that the lectures and everything has been streamed online as well as recorded. So we will be able to go back to the recorded material, share it. We will be sharing it on MO Systems YouTube channel as well as on our website, and we will definitely notify you on our Facebook and LinkedIn pages when they will be available to be posted and shared. Our next, would have forgot. We would like to say a great thank you to Ralph and to Guardian Glass for attending and delivering great lecture. So, Ralph,
Thank you
please
very
accept
much.
this on behalf of Amel System.
Thanks a lot.
Thank you very much.
Like this.
Okay, yeah, thank you. Our next speaker is also a member of the top 4 largest glass manufacturers in the world. It is going to be Pilkington Glass, represented by Mr. Szymon Piruk. Pilkington Glass is also a partner of Amel System. Mr. Szymon will deliver a lecture on the topic of what is the future of the construction industry in the light of the EC directive on the near zero energy buildings. Will the use of BIPV become obligatory? Szymon, please.
Okay. Hello, everybody. My name is Szymon Piruk. I'm a technical advisory service manager for Pilkington in Poland. My lecture's title is quite long and maybe difficult, but I focus on zero energy buildings. So I will tell you a little bit about zero energy buildings and a little bit about the possibilities BIPV and glass cooperation. 2 words about the company. Pilkington now is a part of the NSG Group. It's an international glass company. We are quite strong in the architecture glass and also automotive and technical glass. And all these 3 options are available in Poland. So you can find the factory of the float line in Sandomierz. You can find glass processing factories in Poland, 6 factories, 2 big automotive factories, Pilkington Automotive, and also we have a special factory of technical glass where we produce glass cords for engine timing belts. Today topic is about the zero energy buildings, and this idea of near or zero energy building is connected with all types of buildings, not only new buildings, but also when we are talking about the old buildings, we can make old building also zero energy building by renovation. So this zero energy building is the idea for all type of different buildings. And this idea is not only a European idea, it's a global legislative trend. You can find even in Japan, in USA, and of course in European Union, everywhere, zero energy building is a trend when you can find some legal acts in building regulations, and you can find some targets for 2030 or 2040 or 2050, or even quite short-term targets like 2021, and was in Japan. You can see here that zero energy building has to be constructed now. All public buildings has to be zero energy building in Japan. This when we would like to continue the Japan example, zero energy building ready. This is the first solution when you can see the energy saving is only 50% or more. This is a ZIP ready. Nearly ZIP, it's 75% or more energy saving, or real ZIP is a 100% energy saving or more. What does it mean? That the building has not only energy saving but also energy generation. So this is an idea in Japan how to manage with these zero energy buildings. When you look on the options, how we can change the building and to zero energy building or ZIP ready, for example, here when we would like to reduce mainly air conditioning, or what does it mean? It means heating, cooling, and all air conditioning. But what is the route for this reduction? First of all is a high insulation of roof, walls, of course windows, facades, we need low U value window, and we need good G value solar energy transmittance. All of these values, when we supply, then we can achieve zero or ZIP ready building. NSG have looked at global ZIP calculations, not only in Japan, not only in USA, but global in many different cities around the world. And we can see what is necessary to achieve zero energy building standard. The most important is high efficiency IGU. So IGU is insulated glass unit. It means good IGU for the window, for the facade is the most important thing. Maybe vacuum glazing would be an option in the future if costs would be reduced in the future. And also the extended has the building need smart technologies like BIPV or switchable glazing. Key findings after these calculations: in some places we need very good U value, and in some places we need very good solar heat gain coefficient or G value. So that's the reason that we need offer the best products, best high performance glass for IGUs. What about the European Union? The European Union history of zero energy building or near zero energy building, it started in 2002. It was the first directive of energy performance. And this directive started with certificates for the buildings, for homes, for flats. It was a really big change in the energy performance policy. And also this directive had impact on renovation strategy. Later in 2010 was another directive, we can call it second directive, with NZIP definition, but the definition is not strict. Each country can manage the definition by the independent. So also the second directive was quite important because there was impact on renewable energy. And the last one, the third directive from 2018, is focused on long-term renovation policy, but also building should be ready for the future, for the electromobility and also for the BIPV. European Union legislation is based on directives. And the most important for zero energy buildings is EPBD, so it's European Energy Performance Building Directive, and this is the most important legal because of zero energy buildings. But also you can see here there are energy efficiency directive and also it's renewable energy directive. All these acts are important for the future and for the business connected with renewable energy and BIPV. What was the impact of these regulations in Europe? What has changed? And here you can see a table with U values. It's a heat transfer coefficient for the windows in few countries in Europe. The impact of these directives was that many countries changed from double glazing countries to triple glazing countries. As you can see here, Poland, Germany, Norway, Denmark, also Benelux is starting to be a little bit also triple glazing countries. So all these countries changed from double to triple glazing. Here you can see maximum U value, heat transfer coefficient for the window across Europe. And you can observe that in Poland it's 0.9. It's really good level of the heat transfer coefficient. It's similar to the Scandinavian countries. What else is possible? What changes are possible in the future? I heard that also in UK they are going to change, reduce the maximum U value. So it's also the option for the glass market in the future. And as you can see in the south countries, in Portugal or in Spain, the values are very high. But the real market is different. The real market is slower, and we have some customers. They export windows from Poland to Portugal, and the standard is for sure lower than 2 watt per square meter Kelvin. Result, once again, Poland today is a triple glazing country, and the standard in the window is 0.5 or 0.6 watt per square meter Kelvin, and 2 times low coating, low emissivity coating in the triple glazing unit. As you can see, the Pilkington IGP is a glass processor. In 2020 bought more than 6 million square meter low coating glass. So, and it's increasing every year. Every year is more. So this is future. The low glass will be more and more popular in triple glazing configuration. But also sun protection glass is going to be more and more popular. In the Polish regulation, we have the maximum G value 0.35. So it means that we have to consider to use sun protection glass on the facade or also in windows. Also, the consumption of sun protection glass is increasing every year. Last year was in Pilkington IGP 300,000 square meter of sun protection glass. So, as I said, sun protection is not only apartments, big apartments or offices, public houses. Not today. Also, standard block of flats, we can find a SunCool, so it's a sun protection glass also in block of flats to reduce air conditioning costs. For the photovoltaics, what options we have in regulations? In Poland, the very important is EP index, which is maximum level of this index according to the building regulations is 70 kilowatt hours per square meter per year. And this is really big challenge to achieve for the house this value. And without renewable energy, it could be impossible. And the best option to achieve this number, to achieve this maximum value, is to use, for example, heat pump together with the photovoltaics on the roof. So this is a big chance for the photovoltaics in the future, according to these regulations. What products we have for the photovoltaics and BIPV? It's a special types of glass, Pilkington OptiWhite, which is a low iron glass. When we have low iron content in the glass is much clear, it's more transparent, and we can achieve higher light transmittance, which is very important for the photovoltaic modules efficiency. Micro-white is a special also low iron glass, but ultra thin. The thickness is around 1 millimeter. NSG Tech is a special coating. This is a chemical vapor deposition technology coating. And this is a transparent conductive oxide, which also could be very helpful in some kinds of modules, photovoltaic modules. And, referencing project together with ML System, we supplied Pilkington OptiWhite here in Rzeszów. Here is University in Krakow. Also, Pilkington OptiWhite was used in photovoltaic modules. And here is a combined facade with when you can see sun protection glass and also photovoltaic modules in the not transparent parts. Also OptiWhite was here used for the modules. We were talking about zero energy buildings, but and energy performance building directive. But there is something new. It was published by European Commission in June, and this is a new package of legislation, Fit for 55. And this package is based on the target, reduce net greenhouse gas emissions by at least 55% by 2030. So this is a very ambitious target, and Europe would like to become first climate neutral continent by 2050. But this package is more complicated. We have energy emission trading systems for manufacturers. We have a carbon border adjustment. This is a new thing. And we have we have emission trading system for building and transport. It's a new because it's separately for the manufacturers and for building and transport. We have energy efficiency directive. And we have renewable energy directive. All this, emissions trading system. First of all, what is the advantage of this? We can see only one advantage, that free allowance for flat glass maintained as a benchmark level. So for today, it's nice for the glass producers, but we will see what will be in the end of the day. Anyway, when you look on the red sentence, the carbon price increasing and price of allowances expected to rise. So anyway, this is the disadvantage of this system. Carbon border adjustment mechanism, it's good for the import, to stop import of goods from other countries than European Union, but also flat glass is not included, so it means that flat glass would be still possible to import without any border of carbon border. So we will see what will be the end of this legislation. And also, this is the new, as I said, this is a separate emission trading system directly for buildings and transport. And this is not clear yet how it will work. Theoretically, it should be, the cost should be rather on the side of suppliers, not the end customers, but we will see if it's possible. Important will be also renewable energy directive. This is a target of 9% binding target of energy efficiency by 2030, if the baseline is 2020, and obligation to renovate 3% of floor area a year of public buildings. So this is a really big challenge for investment. What is the most important when we look on the BIPV? Its new renewable energy target for 2030 is 40%, and this is a big challenge and big opportunity for BIPV and photovoltaics. Here is one slide regarding the foundation of fundings for this policy, for this package, Fit for 55. As you can see, Poland is going to be one of the biggest beneficiaries of this program. Here you can see it is for Poland. It's around, I can see it's 17 billion euro per Poland. So it's a lot of money, and this fund will be available as a loan or as a grant, and this could have a big impact on the building industry, in the construction industry, and also for the photovoltaics. As you can see here, the Glass for Europe organization is lobbying for this, and November this year will be the critical month, and we will see what will be the last version of this legal act. So anyway, when we invest all this money in the market, in the industry for renovations, for the new zero energy buildings or near zero energy buildings, we will for sure have many years with increase in the building sector and also in photovoltaics and BIPV sector. So that's all. Thank you very much.
Thank you very much, Szymon and Pilkington Glass for this great lecture. We would also like to thank you on behalf of ML System. And there you go. Thank you. Okay. Our next prelection will be performed online by Mr. Oskar Storm from company Saint-Gobain. Oskar, can you see me? Can you hear me? Dzień dobry, Oskar. Oskar.
That's all I can say in Polish.
Exactly. Oskar works a lot in specification market for Saint-Gobain in Scandinavia. Where are you connecting from today? Stockholm?
No, I'm connecting from a small truck stop outside Kristianstad.
I understand. Oskar's busy on the road. Oskar has been very known and respected for his very active lifestyle in terms of delivering lectures and taking part in various conferences, obviously related to architecture, glass, and more BIPV.
Yes.
Oskar has released a booklet. I've got a hard copy of the booklet here in my hand, and I've got a number of copies. They are obviously in English language. They are free to take, so we are happy to distribute them, obviously courtesy to Saint-Gobain and to Oskar. We have decided to invite Oskar to not to make his life harder, but to ask him to deliver the short speech, the lecture on the topic which is contained within the booklet, and we would be very happy, Oskar, if you could treat us with this lecture.
Yeah, so I'll share my screen. Please say if you see it or not.
I also mentioned Oskar's topic of prelection will be how to design glass facades for near zero energy buildings.
Yes. Can you all see my screen?
Not yet.
Well, it says I'm screen sharing.
Sorry, let me just ask someone from the public if they can see it online. Yes or no?
I'm live, we're not online.
Sorry, Oskar, 1 second.
I am sharing my screen. It says that I'm sharing my screen.
It seems that the screen froze from us, so we don't see you moving, and we don't see your screen
Stop
either.
Sharing and start sharing again.
Mm-hmm. Well, something's moving. We can see the mouse pad. I don't know.
Do you hear me?
Yes, we can hear you just fine. I think
I'm sharing my screen.
I think it might be coming up. Oh yes, we've got it. Thank you very much.
No, it says participants can see your application.
Brilliant.
Sorry for all the inconvenience. It's that way when you're on the road. Designing glass facades for near zero energy buildings. That's something that Energy Performance of Building Directive really wants us to do. And I'm taking the Swedish perspective to see what have we done. And maybe it will become the Polish perspective. I'm not sure. Let's see if I can switch slides. I have to click on my... So I want to divide my short speech into 3 sections. Looking at the operational CO2 footprints of buildings, which is what we do mostly today. And also then to switch over and look at the embodied carbon in buildings. And then from that to say that we need to start doing building simulation, which is a great tradition in Sweden that goes all the way back to the 1950s. So looking at the operational carbon footprint of buildings and glass, we can see that we need to look at spectrophotometrics to understand the development of glass in recent years. The art of regulating the energy flow. If we look at the top diagram here and see it illustrates the energy that is emitted by bodies on Earth. We are all between -50 and +100 degrees, and we emit energy of a very long wave and low intensity. So if we're looking at what's coming from this guy's toe over there, it's somewhere in the range of 50 degrees. And if you would be holding a coffee cup, it would be at 100 degrees. And those are the radiation wavelengths that we want to stop from getting out from the house. That is how we build our coatings, to stop that from getting out. And if we look at the overheating, that can be an increasing problem. It's about the energy from the sun that's trying to get into the building. And the energy is from a body that's 4,500 degrees. So the intensity is a lot higher and the wavelengths are a lot shorter by physics. And that means that there is nothing in common between the energy that we want to stop from getting out and the energy that we want to prevent from getting in fact. So looking at that, we somehow managed to tailor our coatings so that they can meet the different demands. So if we look at the low energy glass that is on top, the red curve here, we can see that the wavelengths that are being let through the window are all the wavelengths coming from the sun. And then it stops at around where energy starts wanting to escape from the house, so that we can get a low U value, but we get a very high G value, it's called, the amount of energy that comes in. And then in recent years, we've been able to develop more and more precise solar control glass that select what wavelengths to come in to the room. So if we look at the most modern glasses, there is no infrared light directly transmitted. All the energy that enters the room comes in the form of visible light. And there is a glass type called the 7033 that I use a lot, because of the glass types that block out the infrared, this is the one that lets through the most visible light. So going to stronger and darker solar control glass means only to decrease the daylight. And with the tight energy rules today, in Sweden, the windows are getting smaller and smaller. So we really cannot allow ourselves to waste any daylight on solar control. So we have to find more dynamic solutions instead. So what we're doing is that we're actually cutting out the visible light and selecting it to go through the windows. The designed spectral curves have led to increased light transmission in standard windows. The low E coatings have improved, so I get like 7 percentage points more light now than I did 7 years ago through the window. If we would continue that way for 30 years, we would have 107% light transmission, which would be really cool. This is for a triple glass windows. That is what we use in Poland and Sweden today as a standard. It gets a very good view to the outside, this type of low E glass. If you look to the left, we have an open window overlooking a lake in Sweden. And to the right, it's a closed window. And it's actually quite difficult to tell the difference nowadays, which is fantastic. And I think almost more fantastic is that with the solar control glass and these designed spectral curves, we can get a good view to the outside through them as well. If we're looking at this villa, the door in the middle is open, and you see that 30% more light comes in there. But otherwise, it's a very small difference in colors, rendering and stuff. And that is a big change. And these things have led to like a lower operational footprint of buildings. And then also to then add energy, to get to plus energy, we can use building integrated photovoltaics. And I guess you've talked quite a lot about that today. My problem with BIPVs have been that they look dull, they look boring and black, and they look like black holes in the building. So I'm happy to say that we don't need to decorate the panels anymore by screen prints and colors that reduces energy. This is the Nationalarenan 3 hotel in Stockholm that's been made together with ML System. And you can see that there is a shimmer in some of the black panels. And it comes from a patterned glass that gives life to the facade. It looks like water when the sun shimmers in it. And this is not a pattern that decreases the energy through the glass. It's actually increasing the energy coming through the glass by 1 percentage point. So we can get both beauty and energy, and so get to plus energy buildings. But of course, adding BIPVs to the building, that sort of, we can say that glass development and building integrated photovoltaics is what will take us into the zero or near zero energy buildings. But then for both the glass and the BIPVs, we need to look at the embodied carbon in buildings, because nowadays that's the big part of the energy that's being used. So if we look at coatings that I've been talking about so far, they make up 2% of the carbon embodied in windows, whereas the weight of the glass is like over 85%. So what affects the weight of the glass? Why is the embodied footprint actually increasing and not decreasing? Well, one thing is that we have increased demands for acoustic comfort. And acoustic comfort means that we add actually weight to the glass, mainly to have less noise coming through the glass. And that can double the weight of a window easily. And then also we have the window sizes. We have to think about what the sizes are of the raw materials in order to save on the optimization. That is not a problem in standard windows, but for facades it really needs to be considered. So how do we get to carbon dioxide neutral glass, which is our target? We have to get there in Sweden by 2045, and we have this 2050 target. So if we look at this backcasting, it shows the importance of getting flat glass to be recycled, which is not today. So if we look at the top light blue segment, we see that that's making the transportation carbon neutral. And then the blue and the orange is about better cutting optimization, better use of the raw materials, and then to have at least 20% of the raw material being colored, because that saves energy and raw materials. So that's actually the most important step, and it's the one that we can help in by identifying buildings sent for renovation or destruction, and to use that glass instead of putting it to landfill like we do mostly today. To take the other fields, the pink and the yellow is about getting green electricity for our floats. Yeah, and then the green part is to use hydrogen instead of natural gas for the float process. And finally, the gray part is that the soda that we use for this soda lime silicate glass that we have today is quite demanding in energy to produce, and it needs to be decarbonized. So we need to stop using fossil fuels in the whole process and recycle more glass. So we've started in Sweden. It's a difficult task of recycling glass. It has a lot of purity demands and stuff. But if we look at the biggest IKEA store in the world in Stockholm, we've replaced all the windows with a 7033, in fact, solar control glass, and recycled the old windows. And the same is being done for the old SAS Airlines head office in Stockholm to the right. You see a picture where the solar control glass has replaced the old glass there. In cooperation with the recycler, Sweden's second biggest recycler, Ragn-Sells, we are investing so that we will be able to take a lot of cullet, as it's called, from Sweden all the way to Poland or Germany, probably in the second quarter of next year, to show that we don't even need to be close to a float to be able to recycle. The only thing that we need to start thinking about, except finding a recycler and a partner, is not to break the glass. Today, if we remove a window, we're very careful until we're at somewhere where we safely can drop it into a container and be satisfied to hear it break. But if we instead store it standing up and hold and on pallets that can be transported, that's the starting point. From then on, it's just like a designed route on how to recycle it. So the focus is starting to shift from the operational footprint in Sweden to the embodied carbon, and that is something that we really need to focus on from now on. So if we look at the next thing, the need for building simulation to reach low energy levels in the building, if we look at Sweden, we can see that the demands are getting stricter and stricter for the buildings. First of all, we cannot, like we did in the 1980s, stop using windows. The building norm tells us we need a good access to daylight, and there are limits in the daylight factor that are becoming legislation and not advice. And on top of that, we have ever stricter demands on the energy consumption. I've talked about the U value before. I don't have time to explain what it is, but today for the whole building enclosure, you need a U value average of 0.5 in Sweden. And it's easy to get low U values in the roof and in the basement, but on the facade it's difficult. So the taller the building, the more difficult it is to reach these demands. And also in Sweden, since 2002, the solution that we choose to meet the energy legislation, it needs to be proven in a building simulation software. And so I'm cooperating a lot with building simulation software, the IDA ICE and ESPO that is dominating in Sweden these days, because they say that if you go by generic solutions, you won't find the correct solution. You need to go by products. So we're entering our products. I also forgot to mention that starting from next year, we need to declare the carbon footprint of the buildings that we finalize. And from 2023, there might be demands on how much solar heat can come in through a window divided by the floor surface, so that the smaller the room, the less energy can enter. And all this together means that we need to use dynamic solutions. We need to have glass plus some sort of a shader, so that when the daylight is there, we just harvest it, and then when the sun is there on the facade, we need to stop it. And doing building simulations early is really the right way to do it. That's what I'm on tour with now. This line here shows that the blue graph shows that the later you make a change in a building process, the more expensive it is. And the yellow graph shows that the later you make it, the less the efficiency. So we really need to start pushing that to early stages, and together with the software developer Equa, we're making templates so that architects and entrepreneurs will be able to make quite simple simulations in early stages with advanced products and tools. And it's called the Early Stage Building Optimization, ESPO, and the method is to use a simple box model developed in the United States, that you have a repetitive facade and you take one piece of it or a few pieces depending on the angle to the sun, and analyze them really careful, and then you can get a result that you can then use for the entire building. So that can help us choose the cheapest solution, and that is often the solution with the lowest carbon footprint. So to the left is a single skin facade with an inside shader, and that's very advanced calculations, full spectral calculations show that actually works. And we have a great number of realized references in Sweden. The Regiones Hus to the left is a prize winner. It's not a rendering, it's a picture. And then if we want to maximize daylight, we might have to go to outside shaders instead, and we've used that a lot. You can see that in the middle building. Those shaders are made of PVC, and the carbon footprint is higher than on the building to the left. And to the right is a double skin where we have the shaders protected by a second skin of glass, and it means that all the windows have to be openable and you need extra glass. So going from left to right, it gets more expensive and the carbon footprint increases. So we need to see if we can optimize to solutions that have low carbon footprints. And this has been a tricky journey for me to get here, and it's been a tricky lecture for you to listen to, but I assure you, if you study the 75 pages that I've written in this booklet, you will be a lot wiser. And those are all my personal opinions and experiences from 20 years in the business. So I find it worth reading. So, and with that, sorry for the slight delay, but that's my lecture for today.
Thank you very much, Oscar. Thank you very much, Saint-Gobain. As I mentioned earlier, booklets are available. So we are happy to hand them out. So please take a copy. We literally have a few minutes left, so maybe I'd like to propose to check if anyone from the audience has got maybe any questions to any of the speakers. I don't think there is any questions, so everything has been described and explained very clearly. I'm sure that if any questions should arise, we'll be happy to answer them offline or through our LinkedIn or Facebook pages. Oscar, thank you very much in that case.
Thank you.
Oscar's lecture concludes our panel BIPV Vision Building and PV Fusion. Oscar, our great thank you in the form of the diploma, the certificate of participation in our panel and this conference will be delivered to you to your home together with.
Well, you could actually give it to my boss. She's in the audience, and I'll meet her tomorrow.
That's correct. That's correct. We will do it.
Okay. Thank you.
Thank you very much. Oscar, thank you very much. Thank you, Ralph. Thank you, Shimon. Thank you.
Tworzymy innowacje w skali świata. W naszej fabryce produkujemy ogniwa, moduły fotowoltaiczne, systemy mocowań, szyby z powłokami kwantowymi, szyby, które świecą. Fotowoltaiczne żaluzje. Fotowoltaiczne fasady wentylowane.